Okay, so 2.2 is about inductive reasoning. We're going to learn about inductive reasoning and deductive reasoning. And inductive reasoning is basically um, observing patterns and coming up with a generalization based on that. So here's an example that we have where, if you turn on a faucet and you turn it counterclockwise, um, then the water comes on. And if you turn it the other way, it goes off. And when you do that over and over again and you see the same result, you make a generalization from the pattern that you noticed. And this is something that we use all the time. We often think about it in science, where you do an experiment and you have observations, and then from that, you draw a conclusion. Okay. And that we call that a conjecture. So it's kind of like a theory. You see something and you say, this is what I think is happening. And so you make that statement. And then you see if it's true, and you might go with it. In geometry, we often think about that and we'll make a conjecture unless there's a counterexample that we can show to prove that it's wrong. So here's another example of a scientist dipping a wire into a salt solution, and every time puts it over the flame, it's orange yellow. And so, um, a conjecture might be that if I dip the wire into a salt solution and then I put it over the flame, I will get an orange yellow flame, right? And a counterexample might be if I put it in some sort of salt solution and I got a different color, then that would disprove it. And in math, a lot, or like one of the ways that we will look at this a lot, is through patterns of numbers and shapes and what we see. And so that's what you're going to be working on here, finding a pattern and looking to continue it. And some of this is just practice and playing and trying and testing ideas out and seeing if it works.